Hello and welcome back to another episode of Let's Build an E-commerce Store with a Spring Boot Backend. Episode 18, what are WebSockets and what are they in Spring Boot? So a rather shorter episode today because this is really a theory-only episode. We're going to focus on what these are and give a high-level understanding. Now, I'm not going to even properly scratch the surface enough to really give you a full grasp. If you're not familiar with WebSockets technology or you're not familiar with WebSockets in Spring Boot, this should give you at least a kind of an understanding. If you're still confused after this, I would recommend going and reading the Spring Boot messaging and the Spring messaging documentation and reading up on WebSockets and the Stomp protocol, which we're going to go into, reading up all of those online because the documents there will make a lot more sense than what I can fit into a 20 to 30 minute video. So we're going to just do a theory episode today, focus on the bits, and then in the future episodes we're going to kind of go into actually developing it. So what is a WebSocket? So let's, I've got a little picture here with a diagram. We're going to show you the differences. So up to now, we've been doing REST API. And what does a REST API look like? So you've got your client and your server, right? So our server is our Spring Boot application. And clients are usually the website, but it could be other systems communicating over REST. So the client first then sends a request to us saying, please can I have some data specified by the request? And then the server responds it back going, here's your data you asked for, it's all good, or there you go, or there was a problem, but you get the idea. It's a single request to response. It happens almost instantaneously depending on your performance of your application, but it's happening in an instance, and there's only one instance of this. Every time you want the new data, you've got to request it. So let's kind of think about what a problem could arise. Well, for example, let's say I've got a list of the products on my page, and all of a sudden one of the products become out of stock. Now, when I've got it on my page, it's already loaded and it's loaded in stock, for example, right? And if I then go, oh, right, well, I want to actually buy this. If you then click into the product and then it comes up going, oh, it's now out of stock, that's going to be rather annoying for a user. So one way to kind of fix this would be, well, let's find that when the product goes out of stock, let's show that on the front end. Well, how would you do that? Well, with REST, the only way you could do that is by requesting this your entire page's information every single couple milliseconds or every single second to kind of refresh, and that's not going to be very performance effective for you on the server side or the client side. It's going to be wasting compute power, and it's going to just waste internet traffic, and it will waste your server's compute power because your server's generating a list of 5 different products to send off to the client's front end, and that's if they've only got 5. Let's say if they're displaying 100. You've got 100 bits of data you're having to load and send off, and you're thinking that's multiplied per the amount of users on that page. Well, that's kind of what WebSockets come in and fix. Because with WebSockets, the idea is that you've got your client and your server, as you did before, but the first one that you send is actually you're opening a connection. Now, HTTP, this is all kind of, it starts getting very low level here, which even I'm not as advanced enough to really explain, but over HTTP requests, you usually send a request and you get a response. But WebSockets is a technology where it can kind of keep the connection alive to be able to feed data back and forth. So what the client does is it sends a request to the server asking to open up a WebSocket connection. The server will then handshake with the connection and go, yep, this is fine. And all of a sudden now you've got an open connection between your client and your server. And then finally, that means you can then have this bi-directional communication between your client and server. Now, that's what just a plain normal WebSocket does. And that bi-directional communication is usually just sending strings of data back and forth. Maybe you serialize it, send it, and deserialize it. But the idea is it's only really strings of data, characters, that you send back and forth. So what is Stomp and MQ? Well, Stomp stands for Simple Text Orientated Messaging Protocol. And it's a protocol that kind of lays out a set of rules for communicating messages over messaging services. So it kind of goes, if you're going to communicate over text, this is how you communicate. So the client and the server both have an agreed upon procedure for communication. The way in which we can look at it in Spring Boot is it's kind of like an MQ for WebSockets. MQ being messaging queue. So since Spring Boot allows us to provide a MQ broker backend to the server, to your Spring Boot app, you can kind of use that as a way to use Stomp over WebSockets. So let's start off by explaining what MQ is. MQ stands for messaging queue. It's the concept of having a centralized queuing system where you ensure that you have that first in, first out approach for your queue of data. So you think of it like you're at a bank and you've got a queue of people at the front. Well, someone who came in first should be seen to first by someone at the counter. Then the second person comes and seen to, and as you see each person, they then leave the queue and they also leave the store at the end of it. So that's kind of what a messaging queue is. It's essentially just a queue, and what that kind of is implementation of the provider-consumer pattern. And what MQs also have is the functionality to define topics. Now, not all MQs do this, but the majority of them do. So topics is the concept where rather than having this queue concept, so again, that bank scenario, so you've got a queue of 5 people and you've got tills at the front where you have 2 tills. Now, a queue would take the approach that the first person at the queue goes to till 1, for example, or whatever till says, oh, hello, come over here first. So the first person goes there. The second person now comes to the front of the queue and they go to till 2. When till 1 becomes available, the third person in the queue will then go to till 3. And you can see that you're splitting along the work and everyone's and one message is being processed by one person. Well, topics is the opposite to that, in the sense that, I know it doesn't make any sense, but let's say, for example, you have the bank and you've got 2 tills and you've got your 5 people waiting in the queue. Well, person 1 would actually be, as soon as person 1 comes into the queue, it then gets duplicated and sent to till 1 and 2. And then the second person, as soon as they come into the queue, they go straight off to till 1 and 2 as well and get duplicated as well. So it's the idea that you have multiple consumers processing the same data, which is what the Stomp approach kind of is for this Spring Boot application, because you have the concept where you've got all of these people on the front end listening for changes of the data, so that when the backend goes, oh, there's some change to the data, they all update to be the latest version of what they need to be. So that's what you're kind of ensuring. So then you can see how queues are then applied to the Stomp, because Spring Boot, what it does is it kind of makes a dummy internal version of an MQ broker to push these messages around to say, oh, somewhere in the code has said there's a new product, and therefore we need to update everyone who's listening to the queue everyone who's connected to the queue listening to this. Everyone who's connected to the socket listening to this queue, they all need to be alerted that there's a new product. Or think about when you're doing your scaling on backend. Well, if you scale horizontally, if you scale vertically, that's not a problem, because you're just increasing memory, you're increasing CPU usage in that server. But if you scale horizontally, where you're adding more instances, well, if one instance is the one that says, oh, a new product has been inserted and you need to alert everyone, well, how does that instance know how to communicate to the second instance? Well, that's where you put your own MQ broker on the back end, something like ActiveMQ, or there's lots of different ones. I think like you've got Azure Service Bus. You put that on the back end, and what actually Spring does is when you say in one of your instances, oh, alert everyone, it actually pings off a message onto that back end MQ broker that you've got, which then all the other instances are already looking at. So it knows to then go, oh, there's some new data, and I need to fire out to my WebSocket connected people as well. So that's how this kind of infrastructure works, is that it's designed so that when you're a small little business, you only have 5 people connected to the website at one time. You don't need to scale your instances horizontally. You can just use the embedded dummy implementation of MQ Broker. But as soon as you want to go, oh, I need to go horizontal, although you might have other problems in your code that you need to address, one of the things you don't need to address is this WebSocket approach, because you can just go into your Spring application.config or properties, set up that information according to the Spring Boot documentation, and you're away, which is really, really nice. It's a very nice way that they've built it. So what does Stomp over WebSocket look like in Spring? Okay, so again, we've got our client and our server again, and just like before, we've got the client's got to open the connection to the server, and the server will then handshake that connection, say, oh, yep, you're okay here, good. And then some time passes, and the client then goes, so you imagine this from your web your web front code, your Angular code or your React code. Think of it going, all right, well, the user's just clicked on the list of products, so now I need to be listening out for what product changes are happening at the current time, because they might be relevant to me. So it will then go subscribe to topic /topic/products, and that will be your message to the server. Now you won't write that message; your library implementation will write that message for you when you do. I think it's like .subscribe, for example, and then you put in a callback method, and that callback method says, "Oh, when you get a message about this, do this." Okay, so then you'll pass some more time, and you then realize, oh, actually, the user is on the product, needs to still listen for the products page, but we're on the checkout now because I need to know about addresses. So I need to still know about product changes, and I still need to know about addresses as well. So you subscribe to topic/user/3 address, and this is an example of how you can have user-specific information being passed back and forth over WebSocket without having to have a worry about still being stateless almost. So having that 3 there, you're asserting the user's ID. So you don't have user/address, which alerts everyone of everyone's addresses, because you wouldn't want that. You're specifically saying only 3. So then some time passes, and all of a sudden somebody went in the back end and or like the back office interface and added a new product. Well, what the server will do is it will send a message off to all the clients saying, I've got a message here for anyone who's subscribed to the topic products, which it knows who has subscribed to it, so only the clients who subscribe to it will receive that. And it'll go, oh, a new product was added, and it will send that information to the client. And the client can then do what it wants with that, be it reload the page worth of data, be it insert the product somewhere, or just ignore it. And then finally the message from and then finally later on a new address was added by the user somewhere else, and the front end needs to refresh this. So we get a new message on topic 3 user, topic user 3 address saying, oh, this address was added, and it holds the address. So this is kind of how this back and forth works. You can see, and then at any point a client could then go, oh, I want to unsubscribe from the products. Sorry about that. So yeah, as I was saying, so at any point you could then go, oh, I'm no longer looking at products, I can unsubscribe from that, and then you won't get those messages anymore. So you're able to manage the amount of traffic that's being sent to and from clients by managing these subscriptions. Obviously, anyone from the front end could write some new code and integrate it into your website or whatever to subscribe to everything. That's one thing, but that's a security vulnerability that you kind of need to manage later on. But for now, this is kind of how it works. So that's the theory behind it. The next episode we'll add a WebSocket stuff into our app. We'll then create our first little WebSocket message for when addresses get added or changed, because remember we did that in the last episode, and then we will test it so you can kind of see it in action. Thank you very much for watching. As always, there's a playlist in my channel that's got all of the videos in order ready to watch. Please feel free to like and subscribe. As always, comment any feedback. It doesn't just help me, it helps other people as well. Like I said, this is a very vast topic. I'm sure that I've probably described 1 or 2 things wrong. This is just trying to give people really basic understanding. If you don't understand it by this point, or if you're still not feeling quite confident, maybe watch the next episode when it does come out to make sure because it kind of helps to visualize it, you seeing it working. But if it still is a bit vague, I really do recommend going and reading some documentation about Stomp, WebSockets, Stomp over WebSocket, and Spring Boot messaging. They're very important bits of tech to understand for this concept. But yeah, thank you very much for watching, and I will see you in the next episode.